Welcome to this How Do I video on monitoring the performance of Microsoft Dynamics NAV 2016 on an Azure SQL database. In this video, I'm going to demonstrate how easy it is to get an overview of Azure SQL database performance metrics using the Azure portal. The tools in the Azure portal allow you to easily monitor the usage of your Azure SQL database resources so that you can scale your resources to meet your workload. Here are the steps we're going to go through today. You might be thinking, why do I need to monitor performance in Azure SQL database? Isn't that the job of the Azure service engineers? Well, there's a good reason. You don't want to pay for more than what you need. In traditional on-premises installations, the purchase of hardware for SQL Server is done up front. You make your purchase based on some estimate of future capacity, which meant you probably over-provisioned based on your future growth plans. When using an Azure SQL database, you pay for capacity on demand, most likely monthly. This allows you to tune your application to use the minimum resources that you need right now. For this reason, you need to actively monitor your Azure SQL database to ensure that you are paying for no more and no less resources than you currently need. This picture shows the relative service levels for the Azure SQL databases. The Database Transaction Unit, or DTU, is the unit of measure that's used to compare the service levels, describing the relative power of the service levels in relation to typical real-world database transactions. So you can see the basic database has 5 DTUs, which means it can complete 5 transactions per second. The standard S0, which I'm using in this demonstration, has 10 DTUs. The DTU is derived from a benchmark created by Microsoft, using a database schema, data population, and transactions designed to be representative of database operations most commonly used in transactional processing workloads. So the first step is to set up a performance alert. You can receive alerts based on metrics for events in your Azure SQL database and other Azure services. For an alert rule on a metric value, the alert becomes active when the metric crosses a defined threshold. And when it becomes active, Azure sends a notification. And by default, notifications are sent by email to the administrator, but you can also define other email addresses, or you can configure webhooks on alerts to route the notifications to any other channel like SMS or chat services. So here's an example mail here showing what you get from Azure, telling me that the DTU percentage on my database was greater than 60% of the allocated DTU during a period over 5 minutes. So let's see how we set that up. So let's switch over to the Azure portal. I'll go into my database and the settings window appears, and I'll look under monitoring. We can see alert rules here. And already you can see my alert rule, which is set up for the database DTU percentage. Let's add another alert. I'll call it storage, and I'll select the metric, which is database size percentage. So this is the size relative to the total size allowed for this level of service. As you can see, I'm currently using nowhere near the level of service. I'm going to set it to warn me if the size increases by more than 70% of the service level. And I'll want an email if that happens. And I'll save the alert. And now that alert's set up. It won't be active yet. It'll happen when it first exceeds that level. So that was setting up an alert. So the next step is just to explain the configuration of the load test. So here's the configuration of the load test that I'm already running against Dynamics NAV, which is running on an Azure SQL database. These are the configurations of the Azure virtual machine and the SQL database, and my test workload, which is for the order processor scenario. There's 50 concurrent users, and they're each running about 100 NAV operations per hour. So this should create a transaction workload of about 3 to 4 transactions per second on the NAV server. I won't go into the details of designing and running the load test here, as that has been covered in detail in the previous series of How Do I videos on performance testing. And configuring Dynamics NAV 2016 to run on an Azure SQL database was covered in my last How Do I video. So now that the load test is running, I can go into the Azure portal and monitor the database performance. I'll switch again to the portal, choose the database, and we can see here on the monitoring tile, if I click it there, it'll bring it up in the metrics window. Here we can see the 3 existing metrics that I've added here, which are the database size percentage, which is still quite small, the IO percentage, and the DTU percentage. And you can add other metrics here, although there's a limit to how many of them you can see. As you can see here, I recently started the load test, and I'm definitely pushing the database to the limit here. I'm approaching 100% of the DTU in the startup, when obviously that's causing a lot of data to be loaded from the database into the NAV server. So you can edit the chart, and you can also add more metrics to the chart by selecting from the list of available metrics here. So now we can see the load on our server. We can start to drill in a little bit deeper, and for this we can use the Azure SQL Database Query Performance Insights. The insights allow you to troubleshoot performance issues by providing more details about what resources are being consumed by individual queries. It shows resource statistics for the top queries which are executed against your database, and it helps you to identify potential optimizations by allowing you to drill down into the details of the queries. So let's have a look at that in the portal. Again, I'll go to my dashboard and click on this Query Performance Insight tab, which will load up the data which has been stored in a Azure data store. So you can see here a graph showing the DTU overall over time. It's showing you for the last few hours, and you can see I've run a few tests here, and these small stacks you can see are the queries. So you can see I'm not really overloading the database with different queries. And if I drill into one of the queries, I'll take this one, number 685 here. It shows me the actual text of the query. And in this case I can see that it's a select on the sales header table, but scrolling down I can see it actually joins in quite a lot of data from other tables. So obviously such a large query would have a performance impact on the database, and here it shows how much of the overall performance is actually due to this query. And it can even show you how many times it's been run in the day, so it might help you narrow down what operations are causing a load on your Azure SQL database. Finally, I'd just like to mention that this feature is still in preview, so you will need to enable it in your portal to be able to see these statistics. So today we've covered firstly the Azure SQL performance levels. We've set up a performance alert against the Azure SQL database. We've looked at how you can monitor the SQL database performance metrics in the Azure portal, and we've looked at how you can get individual query performance statistics from Query Performance Insights. These tools make it really easy to monitor your Azure SQL database when you're running Microsoft Dynamics NAV on an Azure SQL database. It puts together a lot of information which was previously available and still is in lots of other tools like Performance Monitor, in SQL Management Studio with dynamic management views. This has really made it much simpler to get that information in one place. Here's some resources that might help you learn more about Azure SQL database performance. And of course, the Microsoft Dynamics NAV Get Ready page contains links to this and other How Do I videos on performance testing and monitoring. Thank you for watching this video about monitoring the performance of Azure SQL databases. This is part of a series of How Do I videos about performance testing and monitoring for Dynamics NAV 2016. This video was created in collaboration with Microsoft and the Training Center Platan.